So in this video, we're going to review and we're going to present lab 2. We are from group 3. My name is Irfanlai bin Riflai, and my teammate or my friend, his name called Izushami bin Ismail. So in this lab 2, we're going to talk about industrial practices 7QC tools and 5S. So what is the main objective of this lab 2 is that we're going to understand what are 7QC tools and what are they, and how we're going to implementing 7QC tools in the working place, as well as we're going to understand what is 5S actually are and how we're going to use 5S in the working place. So moving on, question 1, part 1, 7QC tools, which is cause and effect diagram, as well as we can call it as a fishbone diagram, or we can call it as a Ishikawa diagram. And it's called Ishikawa diagrams because the people that actually making or create this diagram called Kuro Ishikawa, right? So how we're going to make a Ishikawa diagram is that we're going to have this kind of diagram that is resemble fishbone diagram. That's why we call it as a fishbone diagram. So reading the question quickly, we know that okay, two major accidents usually happen in industry: muscle pain and fall. And then now we need to develop Ishikawa diagram and identify possible cause that may cause muscle pain to occur due to the work of lifting goods, right? So how we going to create this Ishikawa diagram is, firstly we're going to put a title or the problem that we're going to solve on the very right side. There we can see there's a box there, muscle pain. So all of these points are the potential cause and the potential reason to cause this muscle pain, and then in the future we're going to solve this problem. So first is careless of worker. Why careless of worker? Because the worker are very careless, because their lack of awareness, right? The lack of safety awareness, and they do not know what's going to happen to them. And second is lack of safety knowledge. They don't have enough of safety knowledge, that's why they don't have the safety awareness. Following by not following the procedure, and it could be because they are discipline problem. They are not disciplined enough, so they're not following the procedure. And as well as procedure could be not easily accessible and could not be seen in the place that we're supposed to see. That's why the employee or worker cannot follow the procedure properly. Then following with improper material handling, and it could be because they do not have enough training, then they couldn't handling items properly, or the worker are very careless. Next, insufficient skill of worker, and because maybe the level of their education are low, so they're not skillful enough, or maybe the trainings that they attend is less, so they don't have enough skill for it.
Okay, after we draw the Ishikawa diagram and put all the information, we need to do the vote to find what is the critical problems that we need to solve first. And first, and as we know, the first critical problem that we get is lack of safety awareness. The second is lack of training, and the third is discipline problem. So for the first, lack of safety awareness, the action plan is creating a safety awareness campaign and holding a safety awareness talk that been ongoing by Mr. Izul from 20 October to 21 October. So for the number 2 is lack of training. The action plan is create an effective training program that had been done by Mr. Irfan at 12 September. So for the third is discipline problem, and the action plan is monitoring their working discipline and written warning that had been ongoing by Mr. Izul from 19 June to 20 June. So all the data and information has been given, and we can find the X bar and range to draw the X bar control chart. So to find the X bar, for example, in the shift number 1, we can add the data from sample number 1 to sample number 6 and divide by 6, and we can get 2.533333 for shift number 1, and we can do that method at shift number 2 until number 20, and we can get all the X bar. And after we get all that, we can find the average of the X bar, and we get 2.523333. So for the next, we need to find range, and range is the highest data minus the lowest data. So for example, in the shift number 1, the highest data is in the sample number 6, that is 2.8, and the lowest data is in sample number 2, that is 2.3. And when 2.8 is minus with 2.3, we will get 0.5, and we can use this method at shift number 2 until number 20, and we get all the range, and we can find the average for the range, and we will get 0.795. So for the next column, X bar chart, we can see that there is LCL, that is lower control limit, CL control limit, and UCL, that is upper control limit. So the control limit is we can take the average X bar, that is 2.5 to 33333, and for the lower control limit and upper control limit, we can use the data that we get at the table before, and we will get the LCL and UCL. So after we get all the data and the information, we can draw the X bar control chart, and as we can see, the upper control limit that we get is 3.0, the average is 2.5, and the lower control limit is 2.0. And in the control chart, we can see that there is a X mark in it, and it is because there is a plot that had been over the upper control limit. And as we know, the X mark means there is problems, and we need to check and do the inspections.
Moving on is the Pareto chart, and quickly reading the questions. Okay, we are the surface mounted technology engineer, and we're going to present to the management the defect rate for each of defect using the Pareto chart for the 10 production shift, right? So we're going to form this Pareto chart and determine the type of defect that need to be focused to achieve more than 80% of good yield. This basically means that if we have the Pareto chart already, from the chart we'll be able to see which one is the most causing the problem. If we solve that 20% of the problem, we're actually going to solve 80% of the problem, right? So that is the benefit of the Pareto chart. So before we actually making a Pareto chart, the first thing we need is a check sheet. We can call it as a tally sheet as well. So basically, it's a document or a paper that we write down the data on times during a productions or anything, and we're going to write down the defect, and after that we're going to total everything all together, every single defect type. So if you're moving down here, we can see that there's another table that I already arranged, right? Moving on, this is the table that after I arrange everything together again. So after that, we have the check sheet. Then we need to arrange from the biggest number to the lowest number, which is this one. The biggest number will be the 348 for the lifting lead, and the lower number will be extra component for the 18. So after that, we're going to total everything together, and it will become 1,000 total, right? So next, we're going to calculate the cumulative counts, and the way to calculate the cumulative count is basically we're going to take the cumulative count first, and then we're going to add with the total on the second defect, and then after that we can get the answer, right? So calculate like this all the way down, then you will get everything. After that, we're going to calculate the cumulative percent. So the way to calculate cumulative percent is that we're going to take the cumulative count and then we're going to divide by 1,000, which is the total count of all the defect, and then we're going to multiply by 100%, then we're going to get all this answer and then calculate all the way down. So after we have all this table, we're going to go to the Excel and we're going to import all this data, and then from there we can input a Pareto chart. So after the Excel already generate the Pareto chart, which is it will looks like this, right? So the first thing we're going to do is we're going to input this line chart here in the chart, and then after that we're going to take a line and we're going to line up from the 80% all the way to the left side. And then from there, what we can see is we're going to see a crossover between the line chart and with the line from the 80% that we drag. And from there, the crossover, we're going to take another line and we're going to put on the point here and drag all the way down. So from here clearly we can see that it marked down that the first 3 bars are the essential problem that we need to solve first in order to solve the active process of the problem. That's why we are writing here is that by prioritize the problem of solving lift the lids, which is the first one, pivoting the second one, solve the void the third one problem, it will help us to pull out the small set of costs that make up 80% of costs. So this is the benefit of Pareto chart.
Okay, for part 2, activity 1, the question said that the picture above is a picture of a workplace before and after the 5S program is done on this area. List the steps that have been taken to change the conditions of the workplace to achieve the objective of the 5S program. So we need to list the step to achieve the objective of the 5S program. So the step of 5S program that has been achieved in the picture of the workplace is step number 1, that is sort. The trash that is left lying on the ground has been getting rid of. Things that are not necessary, such as extra boxes lying on the ground, have been removed. Step number 2 is set in order. Things in the boxes have been taken out to sort and organize along with keeping in a proper storage box and placed in the iron cabinet. Things in the box include tools, equipment, material and resources. Moreover, the dustbin is moved next to the iron cabinet for an easy location to reach. Next, step number 3 is shine. The floor, iron cabinet and table has been cleaned and removed the trash, grease and dirt. The workplace has been cleaned, tidy and neatly put everything in its appropriate place. The step number 4 is standardize. A schedule to perform a cleaning task has been created to systematically perform the daily to maintain the workplace in perfect condition. And lastly is step number 5, that is sustain. 5S culture is implemented among employees by conducting seminars and training to develop 5S as a habit.
So moving on, activity 2, we're going to suggest an activity that related to 5S program, then we can improve the workspace that already done the 5S program, which is the right picture, right? So what are the activity that we can suggest is that we can actually making a sign for increase the safety in the workplace, because we'll be able to create a visual environment for the employee. And this kind of sign can be found in a varying color, shapes and size, as well as it's going to available in the form that is a floor sign, wall sign or standing sign. With this sign, the employee or our worker can improve their visual communications, right? Besides that, we can do labeling, because we know that labeling is one of the very efficient things that we can do in the workplace to actually increase the working efficiency, right? So anything can be labeled to help keep works area organized, efficient and visual to the worker or employee. So employee can easily understand where things belong and can easily identify when something is missing. It's because everything is labeled, so it's very easy for them.